Hello, welcome back. In this video, we are going to learn about address mapping part 1. So let's look at the agenda. Logical to physical address will be the first point of discussion. Then we will touch upon Address Resolution Protocol or ARP. What is logical to physical address mapping? Internet has two types of addresses for its devices. One is called the IP address, and this IP address is also called the logical address, and the other one is called the MAC address or the physical address. Many a times it happens that in order to transfer a message from the sender to the receiver, the sender knows the IP address of the receiver, but the sender does not know its physical address. This physical address is the NIC or network interface card that is given by the manufacturer and it is installed within the computer. By the help of the IP address, the host to host transfer can take place, but node to node delivery is possible only with the help of physical address. So unless the physical address is known to the sender, it is not possible to transfer the message to the desired node in the corresponding network. So that is why there is a need for mapping the logical address to physical address. So one way to do this is to have a table lookup. In the table lookup, there is mapping of logical and physical addresses. So by looking into the mapping, the sender can know the physical address of the receiver. But there are certain problems. There may be a change of machine. If the machine changes, the IP address may remain same, but the physical address may change. There are some cases where in some LANs, the physical address changes each time the machine is turned on. And for mobile computer, we know that the mobile computer can be connected to different physical networks. So for these cases, there is a difficulty and there will be change of mapping of logical and physical addresses. So we can have two types of mapping tables. One is called the static mapping table and the other one is called the dynamic mapping table. In the static mapping table, the mapping of logical to physical addresses will be static or remain the same. But if there is a change in the addresses, then manually you have to change the mapping from time to time. So this is a drawback of the static mapping table. Whereas in dynamic mapping table, there is a change in the mapping from the logical to physical addresses dynamically and on demand basis. Now let us look at Address Resolution Protocol. Address Resolution Protocol in short is called ARP, and it is a protocol that is used by the Internet Protocol or TCP/IP protocol SOIT in order to map the logical address to physical address. Let's look at it with the help of this diagram. There are two types of messages. One is called the ARP request, and this is a broadcast type of message, and the other one is called the ARP reply, which is a unicast type of message. Let's say there is a device A which is on one side of the internet and it wants to know the physical address of the device B which is connected to the internet on the other side. Now A wants to send messages to B, so it knows the IP address of B. Now this IP address of B is 192 16.5.24. In order to transfer the messages to node B, it must know its physical address. So A will send an ARP request. So this ARP request is broadcast, so it will be received by all the devices, let's say 1, 2, 3, 4 and so on, and it will also be received by this device B since it is broadcast. Now all the devices will be receiving this request, but since they do not have the IP address in the request field, so they will discard it, and it will be B who will know that it is his IP address, and it will reply with a unicast address, and this is called the ARP reply, which will go to A. And this node B has this physical address 6B:74::59:AB. So it will reply to A with its physical address. So A will know the physical address of B, and so it can send messages to B. Now there is a term which is called cache memory. There is a drawback of address resolution protocol, like for sending each IP packet from A to B, each time one ARP request must be sent from A to B. But this is cumbersome and also time consuming. So it is better to keep the mapping that A has received from B in the cache memory. So from time to time, if A wants to send large number of messages to B at a particular instant of time, instead of sending the ARP request each time, it can look into the cache memory to find the mapping. And if it finds that the mapping is there, it can use it. Otherwise, it has to send it again. Let us look at the ARP packet format. The ARP packet format consists of several fields. The first field is the hardware type or H type, which is 16-bit long. Then is the protocol type, which is known as the P type, which is also 16-bit long. Then we have the hardware length H-len, then protocol length P-len, then operational field. This operational field can either be a request type having a field of 1, or it is a reply type having the number 2. Then there is the sender hardware address SHA, then the sender protocol address SPA, then we have the target hardware address THA, then target protocol address TPA. Now this is the encapsulation. Whenever a packet has to be sent, it has to be encapsulated. So encapsulation consists of the first field is preamble and SPD of 8 bytes, then destination address of 6 bytes, source address of 6 bytes, it is of type is of 2 bytes, and data, this can either be ARP request or reply type of packet, and then we have the CRC, which is of 4 bytes long. Now let us look at the operation of ARP. The sender, the first point is the sender will have the IP address. Let's look at it with the help of the flow diagram. So initially the first step, look at the first step, the sender has the IP address of the receiver. So what it does, it sends the ARP request, which is broadcast as its the physical address, the IP address and the target address. Then the message, so it goes to ARP. So ARP is request is sent. It is received by all the devices. So message to the data link layer is encapsulated by the physical address of the sender as the source and physical broadcast address as the destination. Then we go to step 4. The target machine responds. If this is the target machine, it responds and the others reject it. Then number 5, ARP reply, which is the unicast type of message. It is given by the target address. So by replying with the physical address of the target. Point 6. The sender receives it and the sender can then directly send the IP datagram from the sender encapsulated with the physical address of the target, and it is sent to the target device. So this is the operation of ARP. Now there can be several cases. Case 1. Host wants to send a packet to another host on the same network. In this case, the target address will be the address of the receiver. Number 2, the host sends a packet to another host on different network. If it is a different network, then the target will be the address of the router. Number 3, a router gets a packet to send to a host on the same network, then this will be the address of the receiver again. Number 4, the router gets a packet to send to a host on different network, then it will be the address of the router. There is a term which is known as the proxy ARP. It gives us a subnetting effect. We have already learned about subnetting effect in previous video. Let's see how it is done. Let's say we have a router or a host. It is requesting, sending an ARP request. It goes to the proxy ARP router. So basically it is received by all the devices, but if the proxy ARP router finds that it is the physical address, it wants a physical address of any one of the devices to which it is connected, then it will accept it and reply it. Now this proxy ARP router is connected to several devices having different IP addresses. So what it does, it gets the request and then it can send it to the particular device to which it is attached. Basically, the router or the host will not be directly connected to these devices. Rather, it will be connected to the proxy ARP router, and the proxy ARP router will redirect the message to the devices to which it is connected. So this is basically the subnetwork. To summarize, in this video we have learned about mapping of logical to physical address. Then we have learned about address resolution protocol. We have learned about the packet format of address resolution protocol, and we touched upon the operation of ARP. There are 4 different cases where ARP request and reply can be sent. We have also learned about those, and we have touched upon proxy ARP. Thank you.